live in a world totally alien to us. They don't walk. They don't breathe air. They're big!
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by Fish Sticks. Eat more fish sticks. It's the most incredible fish story ever told. Yes, it's the story of fish. 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 It's the story of fish.
Fish have been living on the Earth for over 400 million years. Fish have something that you and I have. Fish had them first. Talking about a backbone. Now, fish backbones let them swim strongly and smoothly, so they live all over the world. There's all kinds of fish. There's long ones and short ones, thick ones and thin ones, and when it comes to variety, fish are off the scale. Get it? Off the scale. Let's see.
¿Qué son exactamente estos animales que viven en un medio ambiente acuático? ¿Cómo funcionan? ¿Cuáles son sus hábitos y características? En definitiva, ¿qué es un pez?
¿Qué es un pez? What is a fish? Well, a peces grandes. ¿Grandes? Hay peces pequeños. Hay peces pequeños. Because they've got it worked out. I mean, I gotta wear this suit just to keep warm. I've gotta wear these weights just to get down. Fish can go up and down all they want. For the fins, you gotta strap them on. Fish have theirs built in. And I can't even get started without this. I mean, I couldn't even breathe. But spine, though, backbone, that I've got. I've got that. Well, anyway, let's get started.
The name is Pond. Fish Pond.
But surely you must know, Mr. Pond, that while fish can breathe underwater, secret agents cannot. Goodbye, Mr. Pond.
All fish have backbones. They do.
You were correct in assuming that only fish can breathe underwater. But unfortunately for you, you miscalculated the depth of the water.
Just like humans, fish have skeletons.
Skeleton.
Skeletons are the framework that support our bodies. Actually, our skeletons are a lot alike.
Backbone.
The muscles that let fish swim are attached to a backbone. Just like the muscles that we have let us walk and wave. Of course, fish don't have hands, they have fins. They're fish for crying out loud.
Come on, everybody, let's give these fish a hand now. Come on, it's really here. Come on now.
Fish swim through the water by contracting muscles attached to their backbone. As they swim, they make a sort of S shape in the water, kind of like clenching your fists. Oh, here, let me show you. Contracting muscles attached to their backbone. As they swim, they make a sort of S shape. As the muscles contract, the fish make a sort of S shape in the water. Fish breathe with special organs called gills.
In order to breathe, fishes swallow water and push a current past the layer of gills.
Now, most fish have their gills at the back of their heads, right behind their eyes, right here.
To provide enough surface area for exchange, the gills are built as row upon row of delicate, feathery tissue.
Now, fish exhale, too. Their gills allow them to have carbon dioxide dissolve right back into the water. The same way our lungs let us exhale carbon dioxide right back into the air.
It's at the gills that the blood is nearest the outside of the fish's body. Here, there's only a thin membrane, and oxygen and carbon dioxide pass between the red blood cells on one side and the water on the other.
So we breathe like this. And fish breathe like this.
Each year, fish scales grow a little. So every line in the fish scale is a year in the life of the fish's... a year...
Scales.
Flexible, overlapping plates that are both strong enough to be protective, yet light enough to let them swim freely.
Most fish have scales. Thank you, that's very nice, but it's not that kind of scale. Scales are kind of like fingernails. They grow right out of a fish's skin. Now, fish scales overlap and slide on each other to help fish take bangs and bumps while they're swimming around in the water. Scale is an old word. Scale. From the Middle English, scale.
Each year, fish scales grow a little. So every line on a fish scale is a year in the life of the fish. Just like tree rings tell how old the tree is.
Some fish have no scales at all, like catfish. Yeah, but most fish have scales, and scales help fish live in the water. In French, it would be escale. It's school to have scales. It's school to have scales. See what I mean? It's a gag.
Now that's all fish tail. Or fish scale. Scale tail. Oh, whatever.
Next on Fish and Chips.
No, man, I'm fish, he's chips.
Oh, okay.
Where does the air come from that fish breathe? Now, please, consider the following. The oxygen that we breathe comes from plants. The same with fish. Only the plants that make their oxygen live in water. Now, fish can get oxygen another way, too. Take a look at this. This is a cylinder of water. And this is a vacuum pump. When I turn it on, I'm pulling all the air from above the water out of here. And watch. It's working. It's working. See those tiny bubbles? Those bubbles are air. It's the same air that fish breathe. Oh, yes, yes. Yes, it's working. Ah. Now, those bubbles are the air that fish breathe. Here, we'll let the air back in. Now, we can measure the oxygen dissolved in this water with this, a dissolved oxygen meter. It says about 8.8 parts per million. But watch, we can mix some more oxygen in with this, the whisk of science. There. See the bubbles forming? They're the same kind of bubbles that form when the wind blows over the ocean, or raindrops disturb the surface, or you may have seen whitewater in a river. All of these processes let air mix in with water. And it's these processes that mix oxygen and water that fish breathe. So now let's measure it. Now it's reading slightly higher, about 9 parts per million, in just those few moments. So fish get the oxygen they breathe from plants, but they also get it from the air when it churns and mixes with water. Well, thank you for joining me on Consider the Following.
Pufferfish. It enlarges its body with water, causing its spines to stand erect. When the danger has passed, the puffer gradually returns to its original, more streamlined shape.
You decide. Fish or not? Starfish. Fish or not? Silverfish. Fish or not? Tuna fish. Fish or not? This has been another Fish or Not.
Salmon are a little bit unusual. They live part of their lives in fresh water and part of their lives in salt water. They might grow up in a stream like this that's full of oxygen and lots of little things to eat, like this one. After salmon hatch, they look like this. They're living in fresh water. These are fry. And out here, salmon are about a year old. They've gotten bigger and stronger. Now they're losing their camouflage because they're getting ready to leave fresh water and head out into the ocean. This is where the river flows into the sea. Salmon come here and hang out for a while and let their bodies change from freshwater to saltwater or saltwater to freshwater, depending on which way they're going. Right now, I'm headed that way, out to sea. Isn't it beautiful? Salmon spend years out here in the ocean, eating and getting bigger and stronger. Then eventually, when it's time, they head back, upstream, to a place like this, where they spawn. Now, salmon don't swim back to just any stream. No, they swim back to the very same stream they were born in. And near as we can tell, they find their way using their sense of smell, the way the water tastes. And once they're here and they've laid eggs, some species of salmon die. And the whole cycle begins again.
Deep beneath the waves, a world of beauty awaits us. We are struck by the gracefulness of these creatures. The fish utilizes powerful jaws to pull the rocks back, creating a safe haven away from predators.
Instead of hands and feet, fish have fins. Now, fish fins have bones in them called rays.
The fins are composed of a thin web of skin supported by rays.
And the skin between the rays is called a membrane. So fish fins kind of work like these fins. This looks like the membrane, and these look like the rays. A lot of fish fins, as they go through the water, form a cup, which allows them to push very strongly on the water they're swimming through. Work great. Of course, fish are better at it than we are. We paddle a canoe the same way a fish uses its fins. See, when I push on the water with the paddle, the force goes through my arms and my bodies into the boat. If I didn't have the boat, it would be hard to get anywhere with the paddle. Well, a fish fin is connected with muscles to the fish's backbone. See, without the backbone, the fish couldn't use its fin very well. It's the same thing. Beautiful day for paddling, for finning.
One kid, one pond, one hook and line adds up to happiness. Fishing derby, which is not like any other sporting event known. There's only so much of a stream, and it's a cinch the fish are heavily outnumbered. There's barely room to swim between the hooks. More than 3,000 of them altogether. For kids from 5 to 15, this is how fishermen are made. Hooked for life.
Fish can swim in schools because they have lateral lines. Now, lateral lines are special sensory systems on the sides of fish. They have very small openings into the water they live in, and the lateral lines let fish sense tiny changes in pressure in the water. So if one side of the school turns, all the other members of the school can feel it and they can turn too. These are sharks. Now, sharks are fish that have been on the earth a long time, and they're very successful. They have a backbone, but the bone isn't really made of bone. Instead, they have cartilage, the same stuff at the end of your nose is made out of. Sharks also don't have scales like regular fish. They have small, bony scales that are very close together.
This magnified view shows these plates called denticles, tiny thorn-like plates in the skin.
That's what gives them such tough skin, shark skin. Now, all these different adaptations that sharks have that make them different from the fish you may see every day are very good.
In many ways, sharks are an example of a life form ideally suited for its environment.
I mean, sharks are very good at living in different places.
They've been a dominant predator in the sea for more than 430 million years.
I mean, they eat pretty much whatever they want. I mean, they're sharks. We'll just, we'll wait on this side of the aquarium. Listen, man, I'm up to my gills in paperwork here.
Imagine, if you will, a motorcycle cop named Fish and his ticket-writing sidekick, Chips. Two backbones of justice pledged to fighting the slime of the ecosystem. They don't know it yet, but Fish and Chips
I'm Fish, he's Chips.
have just entered the title zone.
How many times do I have to tell you? I'm Fish, he's Chips.
all right.
Fish live almost anywhere there's water, except for the Great Salt Lake and the Dead Sea. Thank you.
You live on land, right? Well, fish live in water. But take a look at this. See that water? See that trash? That came from people. Now, it wasn't one person who dumped a whole bunch of trash. No, it's a whole bunch of individual people dumping individual pieces of trash. Now, you want your place where you live, your home, you want it clean, right? Well, so the fish, they don't want it to look like that. They want it to be nice. They want it to be a nice place to live, because I'm going to tell you what. The ocean covers what? Covers most of the planet. See, our home is covered with a place where fish live. So we have to keep the water, the ocean, the lakes, the streams, we have to keep them clean, or eventually it's going to catch up with us, okay? You want your home clean, fish want their home clean.
Swimming to you with my backbone and with my fins. I'm gonna get home, live underwater, soft or fresh, all fish groove wherever it's the best. I'm a soul man, I'm a bass man, I'm a trout man, I'm a fish fan. Now before you get your fishy fill, just remember they breathe with their gills. 'Cause I know all fish, they love it wet. Not stand back, ain't heard nothing yet. I'm a soul man, I'm a strong man, I'm a sturgeon man, I'm a fish fan. Good night, everybody. We'll see you underwater.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some osmotic exchange potentials to mull over. See ya!
Produced in association with the National Science Foundation.
There's one thing to talk about. The fish have no trouble living out here. You know, we call it slime. We say fish are slimy. But fish don't think of slime as unpleasant or anything. They think it is it's important. I mean, they gotta have slime. And, you know, it controls their osmotic chemical exchange with their surroundings. Slime is wonderful. Lets them slip through the water. But look at us. We gotta wear all this stuff and fight with them. We got a backbone, though. Even though they haven't, 4 million years ago.